This video is about the binomial probability distribution. First of all, let's talk about binomial experiment. Consider an experiment for which there are two possible results, success or failure. If we repeat this experiment in a number of independent trials, we call it a binomial experiment. The probability of a success P must be constant for all trials, since success and failure are complementary events. The probability of a failure will be 1 minus P and is constant for all trials. The random variable X is the total number of successes in n trials. For binomial probability distribution function, consider a binomial experiment for which P is the probability of a success and 1 minus P is the probability of a failure. If there are n independent trials, then the probability that there are successes and n minus r failure is this formula, where r equals 0, 1, 2, 3, 4 until n. Probability of X equals R is the binomial probability distribution function. The expected or mean outcomes of the experiment mu equals expectation of X equals NP. If X is the random variable of a binomial experiment with parameters N and P, then we write X is a distributed X binomial. For the formula booklet of IB exam, you are given binomial coefficient is this. Binomial expansion, it will be here. Then for the binomial distribution, the probability of X equals R will be this. And the mean of binomial distribution equals N times P. And the variance of binomial distribution equals NP times 1 minus P. You can use graphing calculator to do the binomial distribution. To find the probability X equals R that the variable takes the value R, we use binomial probability distribution function. To find the probability that the variable takes a range of values such as probability X less than or equal to R or probability X greater than or equal to R, we use the binomial cumulative distribution function. For TI-84 plus, which we are using in classroom, for binomial cumulative distribution function, we can calculate a probability X less than or equal to R. To find the probability X greater than or equals to R, you have to use this formula. Pay more attention to here. This one is X less than or equal to R minus 1. Guided practice 1. Expand this. We can use the binomial expansion formula. So we have 2 over 3 plus 1 over 3 to the 4th power. Let's expand this binomial expansion. You will do, here's 4, 0. Then 2 over 3, 1 over 3. Plus 4 taken 1, then 2 over 3, 1 over 3, plus 4 taken 2, 2 over 3, 1 over 3, then plus 4 taken 3, 2 over 3, 1 over 3, plus 4 taken 4, 2 over 3, 1 over 3. Then you add the exponents. This will be 4, 3, 2, 1, 0, 0, 1, 2, 3, 4. Remember the exponents you adding supposed to be 4. See, you can check. Adding the exponents will be 4. Now let's go to B. 4 chocolates are selected at a random with a replacement from a box which contains strawberry creams and almond centers in the ratio 2 to 1. Find the probability of getting 1 all strawberry creams. According to the given information, for strawberry creams will be 2 over 3. That's the probability. Because the ratio is a 2 to 1. According to the given information, we know this is a binomial distribution. For the first term, it will be probability x equals 4. We got the all 4 strawberry creams. This will be the probability x equals to 3. This is the probability x equals 2. Probability x equals to 1. Probability x equals to 0. Therefore, for the 1 all strawberry creams, you will get this 4 taken 0 and 2 over 3 fourth power times 1 over third to the 0 power. You will get answer 16 over 81. For second question, 2 of each type, which means we're looking for probability x equals 2. So we get 4 taken 2, 2 to the third power square, 1 over third square equals 8 over 27. Let's go to number 3. At least 2 strawberry creams, which means we need a probability x greater than equals to 2. That will be probability x equals 2 plus probability x equals 3 plus probability x equals to 4. So using graphing calculator, you will get probability x equals 3 will be 32 over 81. We already got these 2. So we add them together. You will get 72 over 81. That will be 8 over 9. You can use graphing calculator to work this out. For next example, I will show you using graphing calculator how to work this out. Guided practice 2. Records show that 6% of the items assembled on a production line are faulty. A random sample of 12 items is selected with a replacement. Find the probability that A, 9 will be 40. According to the given information, we know that N equals 12. Probability equals 0.06. For A, which means we are looking for the probability X equals to 0. This is a binomial distribution. At most, 1 will be 40, which means we're looking for probability X less than or equals to 1. For C, at least 2 will be 40, means we are looking for X greater than equals to 2. Less than 4 will be 40, means we are looking for X less than 4 equals probability X less than or equals to 3. When you use graphing calculator for A, we got to use binomial PDF. For B, C, D, you have to use binomial CDF because this is a cumulative distribution function. You can get the direct answer from graphing calculator for B and D. But for C, probability X greater than equals to 2, you have to turn into 1 minus probability X less than or equals to 1. For A, you need to go to binomial PDF, then plug in trials 12, probability 0.06. X value will be 0. You will get 0.476 will be the solution. For B, you have to use the binomial CDF. The X value will be 1. Your answer will be 0.840. For C, you have to use 1 minus probability X less than equals to 1, which means 1 minus 0.840. It will be 0.160. For D, we just need to change this X value into 3. You will get 0.996. Let's go to guided practice 3. If a fair corn is tossed 200 times, find the probability that A, between 90 and 110 inclusive, has turned up. B, more than 95 but less than 105 has turned up. We need to analyze this probability problems. We know this is a binomial distribution. Then for the fair corn means the probability of has turned up will be 0.5. We know N equals 200. Between 90 and 110 has turned up, we can write down probability of X greater than equals to 90 less than equals 110. It equals to this. Remember, here is less than or equals to 89, not this 90. You will get 0.931 for less than equals to 110 and 0.0687 for X less than equals to 89. Subtraction, you will get 0.863. For B, more than 95 but less than 105, I can write down this way. Then, since this is a binomial distribution, I can write down this. The X will be greater than equals to 96, but less than equals to 104. So we can use this formula to figure out the solution. You pay more attention to this is a 96, but here's a 95. After we put into graphing calculator, you will get 0.476. Let's go to guided practice 4. A random variable x has probability distribution function this. We could say this is a binomial distribution function for x equals from 0 to 4. Find this for x equals 0, 1, 2, 3, 4. For A, you just need to plug in. So probability x equals to 0 equals 4 taken 0, 1/2, do the 0 power times 1/2, do 4th power. We'll get 1/16. Probability x equals to 1. 4 taken 1. 1/2. First power. Then 1/2. Do the third power equals. You will get 1/4. Then keep doing the same procedure. You will get probability when x equals 2, 3, 4. Let's go to B. Find the mean mu for the distribution. According to the formula, that mean equals n times p. Therefore, we say for mu equals n is 4 times 1/2. That equals 2. Find the standard deviation, sigma. For this sigma equals square root of this variance. So we get the np times 1 minus p. So we plug in, you will get the 4 times 1/2 times 1 minus 1/2. You will get 1.